I will remind you, okay? So we are mixing in the same skills that we have been working on for the last couple days. The exception now, there's plus signs and minus signs mixed in, and that means you need common denominators. So, you've been doing that since what grade do you think?
5.
I was gonna say 5 too, buddy.
Oh,
Good guess.
so here.
Okay. Okay, so for the first question, all the work's done for you in that the denominators match. Okay, so we don't have to do anything. So now I can go, okay, I know for sure whatever the result is going to be over 28 because the denominators match. And you collect like terms in the numerator. Those look like terms to me, don't they? The 7, I can add 4 and 3a together. That's 7a. Fully reduced? Is that my final answer? How many times is 7 going to 28? Okay, so you get a by 4. Okay? I suppose your goal is to try and get everything to look like that. So that you get all the denominators to match. And then you can start adding and subtracting the numerators. Okay? Do the denominators match in the next question? Close, but they do not match. How do I make them match? Ajmi?
LCM.
Say that again?
LCM.
Oh yeah. Well, they yes, you're right. But here we don't have like it's not numerical anymore. There's like expressions to match, right? And so there is something that I can remove from that second one though. What is that? What is that lowest common multiple is what Ajmit's alluding to, yes? Gabe?
-1.
I could take a -1 out. So if I go like this, okay, I'm gonna get plus. I'm showing more steps than I need to maybe because it's the first time maybe you've seen this. I'm gonna remove a -1, and then that's gonna turn this into -3 plus x. Would everyone agree? It's very literal. I don't necessarily need to see all this work on a test as you get the hang of this. Okay, but I think hopefully we can see that these two components match now, right? They're just written in a different order. Is everybody okay? Now, there's one other catch here in that. That plus sign now needs to turn to a minus sign because you have a negative present. Okay, because it doesn't matter where the location of that negative is. We've discussed this a bunch of times all the way back to grade 9 that there is no difference between these three fractions, and hopefully you agree with me. So just because a negative is appearing in the denominator doesn't mean you can't move it to the numerator or out front, which is what I'm going to do. Okay, in the next line. So I'm going to go 6 over x minus 3 minus now 2x over x minus 3. Okay, and so I get negative 2x plus 6 over x minus 3. Sorry. I thought this was an easier question than I gave it credit for. Everybody see what I did? I can't move over anymore. So, what's the restrictions? X can equal positive 3. Okay. Okay, but what else can I do? Is that fully simplified? Good.
You could take out x minus 3.
And they divide out. So your answer is going to be -2, where x can't equal 3. It's an interesting question. What you these are very difficult, but of all the things that I've had to like relearn over the years, it's probably one of my favorite things to do because it is pretty satisfying to turn something that looks wildly complicated into something that's not so bad. And once you get an idea of how this affects the graph and how to produce the graph, it becomes a little bit of an interesting topic. This is maybe your like, we've done things in the past, maybe grade 10, but I think this is definitely one of these things that like you can take pride in. If you're able to produce these graphs, there is a significant portion of the population that cannot do this. That's kind of cool. Or that's at least the lens I take towards it, right? Okay. All right. What's going on here? What are you always allowed to do? Multiply by what? It wasn't a bad answer. It wasn't the first answer I was looking for, but do we have a fraction in the first term? You can make one. How do you make one? You can put it over 1. You can always divide by 1. How do you make the denominators match now? Listen, I don't care that it's something other than a number in the right fraction.
Multiply by 7x.
Over? Can you just multiply by 7x?
Both top.
Yeah, you gotta multiply by 7x over 7x. That's the same thing as multiplying by 1, which is how you create common denominators, right? So if I multiply this by 7x over 7x, magically, I get a 7x in the denominator, right? And so I'm gonna get 7x squared over 7x minus 5 over 7x. Let me make sure you're good with that. Okay, you know you're right, because if I go to reduce this, what should I get back? I have to get that back. Okay. So, my answer here is going to be 7x squared minus 5 over 7x, where x can't equal 0. Is there any other work to be done here in this question? There's no factoring left to be done in the numerator. Gabe, yeah?
What if you simplify the trinomial on the top?
Is there a trinomial on top? I see a binomial on top. I see 2 terms. How many of us want to do this? No, don't do that. 7x squared divided by 7x, okay, is fine, but that negative 5 is also divided by the 7x. You cannot just go, oh, I'm going to divide this out now. It's not how this works. Because both of those components in the numerator are equally divided by that 7x. We can't go any further. We're stuck. This is as simplified as we're going to get. Okay? Everybody okay? Don't do that. That's no good. Okay? All right, let's jump over here. What do you want to do first? Remember, your goal is always to, Sophie, yeah? Yeah. Make the I'll finish my thing and then you can go. Your goal is always to make the denominators match. So Sophie, what's the thing you see? That's good. You can do any factoring that you can do, just like usual. I would start by just factoring. It's the exact same process that you've been following. Whatever you can factor right out of the gate. So there's only one thing that I can see right now at the moment, maybe. Preemptively, because I've done this before, I know there's a second thing, but for right now, let's just deal with that x squared minus, or x to, oh boy, that's a toughie. X to the 4 minus 4. Okay, square root the first and square root the last, that's a difference of squares. Okay, what's it turn to? Let's find out. That's gonna go where the signs are opposite, right? Plus and minus. And then minus 3 over. What are we going to do here? Okay.
Times it by negative.
Right, not times. We're going to remove that common factor -1 in this component, right? We're going to get that -1, which is then going to flip the signs that exist there, right? And I'm going to see x plus 2. Okay, can we all do me a favor for a second? Let's, for the simplicity of this question, because this isn't very nice, turn that to a, we'll worry about this later. Turn that to a squared. Just so our life's a little bit easier here. Eh? Yeah. So you get x plus 2 times x minus 2 there. So it's still a difference of squares.
Is the sign in the middle supposed to be plus?
Oh, in the in a minute. Yeah, I was gonna do that in a sec. Yeah. Okay, Sophie. Oh, I see what you guys mean. Yeah, sorry. I was concentrating on the other thing. You're right. Sorry. Okay, is everyone okay? I think maybe Dylan's question was this. Should be a plus now. Okay, is everyone okay with that? All right. That's the same reasoning as above. Okay, so that can turn to a plus now. Don't forget those equal signs. Now, what is or how do I produce a common denominator between those two? Because that's your problem at the moment. And remember, when you ask, like, when that's the question of you ask yourself what's missing and how do I get it there? Owen?
You gotta get rid of the x plus 2 at the bottom.
You got to get rid of it. Can you ever get rid of anything in the denominator? Sometimes, at the very end of a question when we go to simplify, yes. But you can't, in like line 2, just decide to get rid of something. So we have to work with it now. Right?
The one on the right by x plus 2.
Yeah, you multiply by x plus 2 over x plus 2. Now I have a matching denominator. Right, so let's do that. So now I get 6x plus 3 times x plus 2 over the matching denominator of x plus 2 times x minus 2. Is everybody okay? Okay, what can I do in the numerator? I can expand. And collect like
There are restrictions now.
it's okay, like, let's do as much simplification as we can, and then before you start canceling anything, state your restrictions. That's okay. Okay? That way we're not doing any extra writing than we need to. Okay, just don't forget to state the restrictions. Okay? So I'm going to go 6x plus 3x plus 6 over x plus 2 times x minus 2. What do we get? 9x plus 6 over x plus 2 times x minus 2. Fully simplified? Are you sure? What's left? Gabe? Hey?
Take out a 3 on the top.
Hey, you take out a 3 in the numerator. Why is that important? I'll show you in a sec. If I remove a 3 here, I'm going to be left with 3x plus 2. Let me ask you a question. What if, after you fully simplify the numerator, something ends up canceling with something in the denominator? That's why it's okay to expand the numerator out, collect like terms, and then try to refactor it at the end, because there could be another factor buried in there that ends up canceling out. Okay, right now we're stuck. There's nothing else to be done. Okay, we're going to simply state x can equal -2 and +2. Okay, go next one. Any factoring to be done in the next one? How do we create a common denominator? Because they obviously don't match. So what are we stuck doing? I actually think this is easier than most people give it credit for. It's just, it's a little bit weird seeing it for the first time. Whatever you see here has to appear here, and whatever you see here has to appear over here. It's the only way to do that. The only way to do that is to multiply each of them by the opposite one. Okay, and over here on the other one, we're going to multiply this one by x plus 4 over x plus 4. Now my denominators match. But remember, you do not expand the denominator. Don't do that. Just leave the denominator alone. Okay, because it's your restrictions. You expand the denominator, you lose your restrictions. You have no idea where the asymptotes are. You don't know where any holes are. You don't know anything, which is going to make graphing it difficult. Okay, you're just going to have to factor it again if you expand it out. So don't bother. Okay, just leave it alone. So we're going to get 4x times x plus 4 minus 9 times 3x minus 1. All that is going to be over the product of 3x minus 1 multiplied by x plus 4. Okay? So now you can expand out and collect like terms and see what you get. Sometimes it's factorable, sometimes it's not. We'll just see. Okay, but number one, do not expand the denominator. Okay, so we're going to get 4x squared plus 16x minus 27x plus 9. Okay, I'll let everybody get caught up to here, and then we'll try doing something. Okay. What's 16 take away 27? Okay.
-11.
Okay. So I'm going to get 4x squared minus 11x plus 9 over 3x minus 1, x plus 4. There should be something absolutely screaming at you right now. Yeah, you're gonna factor that numerator and see what happens, if it's possible. If it's not possible, you're done. You can state the restrictions and call it a day. But we're going to be looking for what? Two numbers that multiply to, what's 4 times 9? 36. And add to negative 11. That's good, Gabe. 6. So let's go through our numbers. All right, 1, 36, 2, 18, 3, 12, 4. Does 4 go in there? Yes, it does. 9 times, right? 5 doesn't go in. 6 and 6. Any of them add to 11? Or any combination of? Okay, so we're done. You can't factor it, it's done. But don't forget about that, because this could factor to something that ends up spitting out something like a 3x minus 1 after you factor it, which is then going to cancel with the other one in the denominator, which is significant because that makes that restriction not a vertical asymptote anymore. It's a hole in the graph. You have to be able to know that, otherwise your graph's going to be all over the place. You know what I mean? That's why this is so important in order to produce these graphs. Okay? You have to be able to do this work. Otherwise, we're in trouble. Okay? Is that okay? So the simplified version there is, because that can't be factored, we're done. But you also have to state the fact that x can't equal negative 4 and x can't equal 1/3. Okay? Okay. We got 2 left. Let's try again. Okay. I'll give you some time to work on these tomorrow in class, okay? But that doesn't mean go home and do nothing tonight. Okay? Might give you another quiz tomorrow. A little one questioner. Okay? All right. Number one, always what? Factor. Always. Right away. Okay, what can be factored here? That one. Okay, so I'm looking for 2 numbers that multiply to 12 and add to 8. 6 and 2 sound right. Okay, that's a complex trinomial, so do not do this. That's wrong. Wrong. Okay, it's going to mess up your entire simplification process. That is a complex trinomial you need to decompose. Okay, so you're going to go, that's going to break into 4n squared plus 2n plus 6n plus 3, which is then going to factor to 2n, n plus 1. Sorry, 2n plus 1. And then I can factor out a 3, which is going to give me a 2n plus 1 again. Okay, and then I can factor out the 2n plus 1s. And I'm left with 2n plus 3. Oh, that's interesting, isn't it? Let's rewrite this whole line here, okay, with that factored version. 2n over 2n plus 1 minus 4n over 2n plus 3 plus 4n squared plus 1 over 2n plus 1 multiplied by 2n plus 3. What's the common denominator? common denominator here looks like that. Just coincidentally. Okay, this question's been designed nicely to give you the same two factors here that you have here and here. So how do I make the other two look like, how do I make the two yellow ones look like, sorry. How do I make the two blue ones look like the yellow one? You just multiply until you get them, right? You multiply by the opposite one, right? So I'm gonna get 2n multiplied by 2n plus 3 over, oh sorry, this is all gonna be over this common denominator now of 2n plus 1 . Okay, and now I can expand the numerator, collect all the like terms, factor the numerator if possible, and hope for something to end up canceling out. That'd be nice. It's not always the case, but it would be nice. Okay, so let's just expand out the numerator and see what we get left. We're gonna get 4n squared plus 6n minus 8n squared minus 4n plus 4n squared plus 1. All that's going to be divided by 2n plus 1 times 2n plus 3. I'll move it up, sorry. What else? Okay, what's going to happen here? Looks like when I add all this stuff up, 4n squared plus 4n squared take away 8n squared is going to give me what? Nothing. You're going to get 0 for the n squareds. What about 6n minus 4n? I just get 2 n's. So the blue component 0 pair out. Who's that? How do I decline that? There you go. I don't know who that is. Oh, they've messed up my iPad now. There we go. Okay, so we get 0 for all the blue components, and I get 2n for the red components plus 1. Over 2n plus 1 multiplied by 2n plus 3. What happens? But
You have to
state the restrictions. N can't equal
What?
2n plus 1 can't equal 0. 2n plus 3 can't equal 0, which makes n can't equal -1/2, and n can't equal -3/2. Okay, and then fully simplified, we're going to get 1 over 2n plus 3, where n can't equal okay, I'm going to stop there.